Hi, my name is Jamie Kelly. I also work for BJSS. I work as a lowly platform engineer. I'm not a cloud consultant. That's those two jobs. I'm going to talk about DynamoDB pricing models because I thought that would be exciting, sort of. See if I can move that out of the way first, because that will really get on the nerves. Wonderful. So quickly before I start, can I just get a quick hands up of everyone who's heard of Dynamo? Has everyone heard of Dynamo? Most people, wonderful. Who's used it, played around with it? Who's got it in production? Wonderful. I can just say pretty much whatever I want. So today I'm going to cover over a little bit of what Dynamo is. Most of you seem to already know about that. Also, green laser, that is awesome. I don't think I've ever had one that's not red. Have a quick talk about what DynamoDB is, and then we'll go through a couple of different pricing models, and then I've actually done some maths. Please don't try and actually see if it works out right. I'm sure it does. Don't prove me wrong. We'll cover that in the examples question, and then there may be a little bit of time for questions at the end, but I think most of it's meant to be saved for the panel discussion at the end. So 15 minutes. The talk is definitely longer than 15 minutes, but I'm sure we'll get through most of it. Of the 57, by the way, in this corner, I don't have 57 slides. It counts one per transition. I don't know how I'd be able to get through that otherwise. So DynamoDB, what is it? DynamoDB, so it's a key value and document store. So a lot of people call it a NoSQL database, for example. Generally, you give it a primary key, you get an item back. It's an AWS managed service. So by a managed service in AWS, AWS will provide things like S3 and EC2. These are fairly core infrastructure offerings. DynamoDB is much more of a managed service. You don't have to look after the underlying hardware. You don't do security patching. You don't have to worry about other bits and pieces like scaling it. AWS manages a lot of it for you. You tell it you want a table, tell it a couple of configuration options, there, sorted. Automatically scales. In terms of storage, I'm mostly talking about here, there is some auto scaling in terms of capacity and throughput as well, but mostly I'm talking about you don't have to say it's going to be about 100 gigs worth of data and then have to worry about crap, I'm running out of space, need to make it bigger. It will just handle as much as you can throw it. If you're actually reaching to the point where you're getting limited on how much you can scale, don't take advice from a 15-minute talk. Can be relatively cheap. I've used two words to get out of this, can and relatively. If you're using it in the right way, it can be a lot cheaper than using other ways of storing data, but it's hugely dependent on actually getting it A, set up right, and B, using it correctly. One thing that a lot of people seem to think to begin with was that document stores and key value stores are great. Just chuck whatever you want in them, and then we'll worry about how we get it out later. To actually get the best usage out of things like Dynamo, it's best to know how you're actually going to be accessing that data. And if you can do that, you can get it working very cheap indeed. And it's fast, really fast. Single millisecond latency. That's off of the Amazon webpage. I've not measured it, but I'm going to take their word for it. Seems pretty good. It means you can actually use it as a cache. I've used that in a project before. DynamoDB was used as a cache in front of an SQL database. Very good reason for it. Not going to go into the detail. And that's what an item can look like if you get it back. So your primary key would be something like the author and the title combined. So you would have the partition key, it's called, and then the sort key. Composite together, that will give you a primary key that you can use to access some data. You can also just use a partition key. So that's roughly what DynamoDB is, for those of you who aren't entirely sure or needed a refresher, and so that I can remind myself. Next stage, DynamoDB pricing. So there's two main ways of doing DynamoDB pricing. And they are the provisioned capacity. So this is where your billing model is that you're basically paying for a set amount of throughput. And you're getting that throughput fairly consistently. You go above that throughput, you're going to start getting throttled on it. The other way of doing it is on demand. On demand, instead of paying for throughput, you're paying basically per request. So you've got a model where you've got provisioned throughput. As long as you don't go above it, you're fine. And on demand, it'll sort all the throughput out for you, more or less. And you pay per request. Yeah, this bit, right pricing structure, depend on your workload. There's no one is better than the other. There's one that I think everyone should probably be using most of the time, but it depends what you're doing. That's why there are two options. If there was one that was always better than the other, they'd only offer one option. Provisioned capacity. So this is the first one we'll have a quick look at, and then we'll have a look at the on-demand. So Provision capacity, I'm going to have to look at this to read this one. Provision capacity is a reservation of throughput measured in write capacity units and read capacity units. And soon we're going to get to read request units and write request units, and it's a little bit muddling. But yeah, you're basically, as I say, you're reserving a certain amount of throughput. The capacity units that you set on the table determine the number and the size of requests that you can make before getting throttled. You'll still be able to make as many requests as you want. You'll just get throttled on a load of them. The service won't break. You'll just get a whole load of throttled requests. So what is this write capacity unit? One write capacity unit, one write request, up to 1 kilobyte in size per second. So a few examples: 5 writes, 1 kilobyte per second. It's going to be 5 write capacity units you need. 5 writes of 2 kilobytes, it's going to take 10. And 1 write of 5 per second is going to take 5. Fairly straightforward to work out how to use write capacity once. Then you get to read capacity. It's great. Half a read capacity unit will give you 1 read request up to 4 kilobytes per second. Or, if you're using strongly consistent, so that's for eventually consistent data. So it could be a tiny bit out. I think it's about a second it could be out by. 1 read capacity unit will give you 1 read request up to 4 kilobytes in size per second that's strongly consistent. And then you have the transactional cost, which is double that again if you're making a transactional request. Right. More examples of the read ones. 6 reads of 4 kilobytes, 3 RCUs, that's fairly straightforward. If you're doing 6 reads of 1 kilobyte, it's still going to cost you 3. This is for the eventually consistent ones. And that's because it's still each individual request is going to take up those units. 6 reads of 5, it's going to double it because you're going over that 4 kilobyte limit, and 2 strongly consistent reads, 4 RCUs, and then the transactional one. So that's kind of how they add up. It's per request, and it depends on how big the piece of data is coming back. But to be honest, 4 kilobytes, you can fit a lot of stuff in. On demand is, I was going to say completely different. It's not. It's almost exactly the same. You just kind of miss off the per second bit. So on demand is a pay per request model that's measured in very similar acronyms that are slightly different: write request units and read request units. And I did copy and paste a lot of this, and I'm really hoping that I didn't get the wrong acronym in the wrong place. But we'll see. It'll be fine, I'm sure. There's no capacity to set. So the interesting thing with Dynamo on demand is the capacity of DynamoDB on demand. 2,000 write request units and 6,000 read request units to start with. That's what's called the peak of DynamoDB. And so it can automatically handle from when you provision the table up to double what that peak is. So if you start a brand new on-demand table, it can straight away handle 4,000 write request units and 12,000 read request units. And if you've got something and you know it's going to be taking up a hell of a lot more than that straight away, so 10,000 writes and 20,000 reads, you can actually just preset it on the provision capacity to that high, switch it straight over to on-demand, and it will keep that as the previous peak. So this is going to be really familiar. 1 write request unit, 1 write request, 1 kilobyte in size, basically just dropping the per second. Throughput's already worried about. All you're doing is measuring how many reads and writes you've got. So again, for the reads, it's pretty much exactly the same numbers. You're just losing the per second bit because you're paying per request, not paying for throughput. And that is a whole load of stuff to take in without some solid numbers on it. So, having gone through these, exactly the same examples we were seeing before, you're just missing out the per second side, just to give you an idea that the units, whilst not completely interchangeable, you can do the similar sort of maths on them. Examples. Human body. So, I've got 2 examples for you. One is a consistent load, so we're going to actually put some numbers to it so we can see the difference in cost. Consistent load, so we're talking about 4 kilobyte. That was definitely 1 kilobyte. Mustn't have got the updated slide. That's meant to read 1. Ignore the 4, otherwise the maths does go wrong. 1 kilobyte items, 100 writes per second, 8,000 eventually consistent reads per second throughout a month. If you've got this sort of consistent load, this is where the pricing model of provisioning it beforehand is really going to pay off for you. So if you're doing provisioned writes, you're going to take about 400 WCUs plus 10% headroom, so 440. And provisioned reads do the same. Take what you need, add 10% just in case it's a little bit over. So those are the numbers we're going to work off of. On demand, I did do the maths for this, I promise. It's not just made up. 250 million write request units and 10.5 billion read request units. So those are the numbers that are based off of, so AWS, a lot of their documentation over a month, they say, is about 730 hours. So that's how I've done the maths if you do want to try and replicate this. So how much does that actually cost? Because that doesn't really mean anything at all. That's the monthly cost for the provision pricing on that. That's going to cost about $708, about $700, paying for those requests per hour. So you've got that provisioning all across the month. It's going to cost you about $700. If you're paying per request, about $3,000. It's about 4.5 times as expensive. So if you've got a static load and you can consistently say it's always going to be about the same, it makes so much more sense to always just go provisioned. However, if you've got a daily spike, and again, that was meant to say 1. It said 1 about 3 hours ago, I'm sure, maybe. It definitely says it now. If you've got the exact same load, so 100 writes per second and 8,000 eventually consistent reads per second, but you're only doing it for an hour every day, that's a very different workload. And if for the rest of the day it's, say, 100th of that, so 1 write and 80 reads, then the numbers change fairly dramatically. Not for the provisioned one, because you're still provisioning the same amount to account for that spike, but on the on-demand requests, they drop significantly. So instead of 250 million and the huge 10.5 billion or whatever it was earlier, you're slimming down to under 15 million writes and just over 600 million reads. And that really changes how things are priced up at the end of the month. So provision still costs the same. It's provisioned to be able to take that load. But on-demand drops significantly. So that drops down to $200. So you're now less than a third. This doesn't just have to be a consistent throughout the entire month, you're always hitting it the same. If you've got something that's a bell curve, that'll also work because provision does have auto-scaling capabilities. Definitely don't have the time to go into all of that. But basically, if it's consistent and the way where it ramps up and ramps down fits in with the way that Dynamo does auto-scaling, it's always going to be cheaper to use provisioned. But if you do have that kind of bell curve and you've got spikes at certain times in the day, but they're predictable, you're going to have to do a bit of the maths yourself to work out whether it's going to be able to actually ramp up quick enough, because in some cases, DynamoDB won't ramp up quick enough. On demand for anything that's spiky or unpredictable or really low volume workloads as well. Pretty much everything I've actually worked with ends up falling into this. It ends up being cheaper to just go on demand rather than try and work out whether you can have a low enough provision capacity but still be able to account for a spike, or auto scale it, but does it actually happen quicker? A lot of times, stick it on demand, it's going to be fine. I would say if you're contemplating between the two, unless you know that there's a good chance provisioned is going to save you money because you know you've got a very consistent workload, just go with on demand. You can always change it if you really need to. But more importantly, do the maths. You can work it out. AWS has got the pricing on there. You can work out how big your average item size is, and you have some idea of the request weight. You're going to be able to work out how much it'll cost. And just as a ballpark figure, if you've got 1 write capacity unit and 1 read capacity unit, then that's the equivalent of about 380,000 requests every month. So if your Dynamo table is taking less than that, then it's automatically going to be cheaper to do Dynamo. This is from a live project that I'm working on currently. You can see the date, February, March. This is just, the day's just gone, that was this year. So I was advising them on how they could potentially save some money on Dynamo. That was all pre-provisioned. 21st, you can see pre-prod went to on-demand halfway through the day. So we've got half the cost provisioned, half on-demand. And then that's where our pre-prod environment was all on-demand, but prod was still all on provisioned. And then, as you can tell, this is where we went straight to on-demand. So for this particular workload, and it says about 30,000 request units per day were being used, significantly cheaper to go on demand by a huge amount, actually. They were very happy with that, surprisingly. And that's about it. So does anyone have any burning questions before I hand over? Wonderful. Oh, well,
you don't get away that easy.
Oh, no.
Nice try.
Hang on, who put about Route 53? Because I love that, whoever did it.
It's a reference to Winnipeg.
Yeah, it is. That's why I love it.
Yeah. Are you going to want some of those?
I'm sure I'll be able to. Maybe.
Sorry, I have one question, if you don't mind.
Yeah, sure.
So, is it possible to switch between one price model and the other?
This question.
Or how easy is it to switch?
Yeah. Okay. So how easy to switch between provision and on-demand? Very easy. So you can switch once every 24 hours between the two modes. So you can't just switch to one and then go, oh, now I need to switch back quite so easily. It takes a bit of time. So switching between provisioned and on-demand, we did recently, as I showed you. It takes an amount of time on the order of like 5 to 15 minutes, or could take a bit longer, I suppose. It depends on the table itself. But you flick a couple of options in Terraform or CloudFormation, because you're not going to do it in the console. Obviously, none of us would do that. And yeah, 10 or 15 minutes later, it'll be ready. The important thing actually when you're switching between provisioned and on-demand is that you don't have downtime. It carries on with the previous capacity fine. So if you've got capacity set and provisioned and you switch to on-demand, you're not going to have any downtime. You're not going to lose any traffic over that. It will just gradually switch and then it'll be ready. Did I answer that one?
Want to take the Route 53?
Yeah, Route 53. Quinny Pig's awesome. Love it. There you go. Route 53 is the best database you can possibly have. There's that one done. Best way to monitor the performance of Dynamo so I can get insight to cost optimize it. Okay, great. So this is if you've already got something running to optimize it, or yeah, so it's monitoring performance. So if you've already got Dynamo running, there are already some metrics that are getting exported to CloudWatch. And if you catch me afterwards, I can probably find you exactly what it was. I wrote a script a while ago. It was about that long on the monitor-ish. And that script would go and find all of the tables that I had. And it would go and get the provisioned capacity for all of those. And it would work out from the pricing of provisioned capacity how much that cost. And then it would also go and get the consumed writes and consumed reads. So those are metrics that are exported as well. And you can take those and work out on the on-demand cost how much it's going to cost you. So I did have a script at one stage to do it. If you follow that sort of recipe, you can print out a little table that says you're spending this much and it would actually cost you far less if you went on-demand. Or it will tell you even far more. Why do I want to use document or key value store like DynamoDB? Depends how long you've got to answer this question.
30 seconds.
30 seconds, right. Okay, so if you know how you're accessing your data and you can build a DynamoDB table in the right way, which isn't as easy as some people think it is, you can have a super cheap, super reliable database, and that's why I've generally used it. So we've got, I've had live loads running through DynamoDB on projects that are running now that are costing less than $1 per day. So the cost savings are immense and you don't have to worry about managing it. But that's a much deeper question. So whoever asked that, if you want to catch up with us afterwards, depends which side you're attacking it from, really.